it goes with that of the elasticity. You can't talk about the elasticity of the rock without mentioning the deformation that will come along with it, which is the strain. So now, we want to have a look at in situ and laboratory testing of rock. So usually if we want to test for the properties of the rock, we try as much as possible to pick the portion of the rock that is free from any kind of discontinuity, so that we can get the exact true values or true strength values. So you just imagine that big mine you are working in. Then to determine the rock properties to influence our design, we only pick samples that look like this to the lab for our test property. And this is going to be a representation of the strength of the rock you have there in your mind. What comes to mind? So it means if I pick any sample that already has failures on them, I will end up testing and getting lower values, which will mean that the rock is not competent enough. And so I have to inform management. If really the mineral we are interested in is of a higher grade we can't do without, then it means they have to provide extra funds for us to provide support. When in natural sense, the rock itself was competent, but because we didn't pick our sample as the right locations. And so to pick our sample for testing in the laboratory, we pick ones that is free from these joint sets. And we pick an intact rock. Intact rock meaning a sample or a portion of the rock that is free from all other discontinuities. So let's see this other one. So geotechnical mapping and rock mass classification. So when you have gotten all your mechanical properties and you have an idea of the physical properties of your rock, the next thing we do is to look at the qualitative properties of the rock. So we have the quantitative ones and the qualitative one. And the qualitative ones usually we term as the rock mass classification. So I have subjected the sample to test in the lab and all that. Then now, what do I see visually when I get to the field? Just like Mr. Tambila said, that when we get to the field, although we are into operations, but it is good that when we get to the field and we also observe some few things, we can share with whoever is in charge of that aspect of our operations to come and resolve them. And so that eye or those things we do on the field as visual inspection to supplement or complement the laboratory test are what we term as the rock mass classification. And some of the things we do, so it says that in order to produce geological maps and description of engineering properties, so we want to describe properties of the rock mass that can be used with confidence in design. It is important to have a well-defined process that produces comparable results obtained by different personnel working at several sites. So the classification system is such that if we all are geotechnical officers, the 5 of us here in this meeting, then we happen, if I ask Mr. Dolo to get to one site of our mine, can anyone give us an example of a site in his mine, a particular location? Good, 17 level stope. Then we say Mr. Tambila should go and have a look at the place and provide a feedback. He will have his own criteria because these classifications are usually subjective. So he will get there, maybe raise the marking scheme and come and say, no, 17 level. In fact, it is deadly. If you dare go in there, I don't think we will make it. You see, his description and his marking scheme, the standard he is setting, might vary from if we send Dolo there. Or Sodio should go to that same place. The same place, we will all go there and come back with varying opinions in terms of the assessment of the stope or the area. And so to avoid that, researchers decided to come up with these classification systems that will give us certain clues as to what we should look out for and what rate we should give it. So at the end of the day, when we have all of those things put together, we can quantify and say, okay, the rating is 20%. 20% we all agree is not good. Hence, the inception of rock mass classification. So then, to meet these requirements, standard mapping procedures are supposed to be done. So sometimes we need to do geological or geotechnical mapping on the surfaces to pick the joint set numbers, the persistence, and all of those spaces within the rock. And so we have to do geotechnical or geological mapping, we use a line or a window mapping. So with the line mapping is a situation where you just decide to pick a tip and stretch it over a surface of about 100 meters. And then along that 100-meter range, you are describing what you see within that 100-meter stretch. Come up with all the properties that you can think of within that surface along that 100-meter stretch. Then we also have the window mapping, where you are trying to create an imaginary segment or grid on the surface of the wall, and then you describe the properties that exist within these windows or these grids that you have there. And so these are the two basic approach we can use in determining the geotechnical properties of the surface of the rock, most especially the walls of the pits, the walls of the stope. Then we have on the surface of the rock, what are some of the things we can see? We can tell about along the tip, you can tell how the various discontinuities are oriented. You can tell the spacing because it is a tip. You are able to tell if there's a discontinuity, what is the measurement between from one broken wall or one broken block of rock and that of another block of rock. What is the amount of space provided there? Okay, so these are several properties that we can see when we are dealing with geotechnical mapping. So an aperture, we can look at the depth, the orientation, the other orientations that may occur within the rock samples, the discontinuity sets that exist there. So if I have a discontinuity and another discontinuity, what are the types of them that we can see in the surface? We can see the wall strength or the width of the broken walls to measure the spacing that exists between them. So all of these things are things we can see when we go for these types of mapping. So someone decided to come up with an approach which we shall get to very soon. Beniersky in 1979 gave some description and some rating that you can give to it. So if I get to a surface and I see that it is rough and unweathered, it's a wall rock, tight and discontinuous with no separation, no obvious separation, although there's a crack on the surface, but there's no obvious separation. Let me see if I can get a typical example of that for us to see. So let's have a look at this particular rock sample I have in my hand. So you see, if you look carefully at this rock, you could see that there has been this, it is very discontinuous. When I look along this line, there are several cracks all over, but then it is not obvious. You don't see any obvious separation within this sample, but there's a failure along it. And so if I have a rock sample on the surface, I am trying to pick my data to go and describe my rock, and I see some of these features, then I can easily use a rating of 30, because although it is discontinuous, but unfortunately, these discontinuity I see there are not providing any obvious separation along it. But then if there were to be some huge gaps within, then there is separation between the samples. And that is what we are describing in the first instance. All right, so let's have a look at our next slide. So to determine these properties or these ways of describing the rock in the rock mass classification, the godfather that first proposed these classification principles was a man known as Terzaghi. He was more into soil, and so he decided to come up with some of these principles. He said that his approach was more of description of the rock, which is what we just addressed earlier, saying that if you give me a description without values allocated to them, my opinion might vary from another person's opinion. And so at the end of the day, we get to the table to discuss, and everybody has different views. We don't have any definite value to use in our discussion to draw conclusions. For example, you get there, you come and tell me that, oh, the rock is intact because it contains neither joints nor hair cracks. Another person's get there and says, no, I could see some stratified layers there, and so I can say the rock is stratified. It consists of individual, but remember that one particular rock surface you are looking at may have all of these. So what do I do? And so, although he was the godfather, but his principle didn't hold water. People could not use it the way it's supposed to. And so out of it, other measuring rules were proposed. Although he brought it, but his own was more or less modified by other researchers, and we got a more advanced and a more accurate ways of describing. A typical example is the one we saw earlier, where you describe the rock thoroughly. If I think that the description I'll give to the rock falls within these, I give it a value. So at the end of the day, we are at the meeting, I have a value I am talking to. So if I gave it 25 and you gave it 30, at the end of the day, we can find the average of the values we have each allocated. And then we have a central value to draw our conclusion.